In this video we're going to learn that sometimes when you make a loft or boundary you have to make more than what you need, and then later on you cut it back to get the final shape that you desire. We'll also learn that you can use a loft or boundary as a bridge between two major bodies. This example is just a watering jug that you can find for a few dollars at the store. It's plastic molded, consists of the main jug area, which has a spout formed into it, a handle, which is a simple resolve, and the bridging section, which is supposed to be blended into the jug and into the handle. Take a look at the starter file, and we see in the front layout it's just the basic shape of our jug, handle, and bridge. In order to execute this, we are actually going to have to build a boundary that starts at the base of the jug and is going to go all the way up to the top where the spout is, and later on we're going to cut away this excess material. That means that we need to have some guide curves that aren't going to end just here or end just here, but are going to have to go all the way up to some sort of plane in this area that will, and also have some profiles way up here that we can make our boundary up to, even though later on we're going to cut that material away. To do that, I've added a sketch on top of the original layout. I'll edit this. What this sketch does is copies the original contours from the first layout and extends them as necessary to a common line, which will be defining where a top plane is for a top profile. So this line here is extended with an extra line here, and the extension on this line was short enough that I was able to just drag this line up to the top here. Similarly, I took this line of the handle and stretched it all the way up to this line as well. On the right plane, for simplicity, I just went ahead and drew a single curve that goes all the way from the base of the water jug up to this top plane here that we have yet to establish. In reality, the jug in this area is going to end right at this point, but we need this curve to continue all the way up to this common top line because our boundary is going to go all the way up to this line before being cut back with this line. This will be a little more clear as we move along. So we added a profile plane passing through this line here, and another profile plane passing through this very topmost line that I've been talking about earlier. Now sometimes it's convenient to have temporary profiles that will not actually be used in the boundary. The first temporary profile represents the base of the jug. This was created by making a spline, mirroring it about this line to create this other side. So the base of the jug is symmetrical in all directions. The second profile represents what the jug would look like at this cross section if it did not have a spout blended into it. So again, we've drawn a spline going from this point to this point and is mirrored over to this side. The last represents what the jug would look like at this line or cross section, again if it did not have a spout blended into it. This is a spline, pierces this curve here, mirrored about this line here to create this second half here. What we're going to use these for are underlays to help us figure out what the total profile should look like when the spout is added into it. First profile that will actually be used in the boundary will be P1. This one is just a simple copy of the profile 1 layout, so we won't look at that anymore. The second one is P2, which is a copy of the Profile 2 layout, which copies this line here, but then has a new line drawn in on this side, which has the spout area blended into it. And we can see the underlay of the original Profile 2 layout sketch, which is being used as sort of a visual guide just to get a sense for how to blend this spline in this area into the spout area. That way this jug will be reasonably symmetrical in this area until it gets to the spout. Similarly for P3, the same idea is used, where this area here is copied from the Profile 3 sketch. This area here is a spline drawn in to include the spout, and this line here is just being used as an underlay to kind of help us guide what the shape of this should be look like. Going to have a back guide for a boundary copied from the front layout, a spout guide copied from the front layout, and a side guide copied from the side layout, which is that extended sketch all the way from the bottom to the top. All of these guides go from bottom to top, even though that isn't necessarily how far the eventual jug will be going once it's been completed. Going back to our example file, I'll just roll back to the first step, which is nothing more than a boundary, which is including in direction 1 P1, P2, and P3, and in direction to the guide curves I was talking about before, the back guide, spout guide, and the side guide. No controls are being put on any of these. The handle, step 2, is a simple revolve. So I've copied these lines from the front layout, and this is being revolved about this line. The next step is cut away some excess material on both the handle and later on the jug. This line is copied from the front layout, which we can see here, and then extended a little bit just by dragging the endpoints to guarantee that this line is going to cut completely through this revolved handle. And this cut has to go to this side to get rid of this portion of the handle. When doing this, make sure that the only body that's being cut is the handle body. So under the feature scope, for the handle cut, choose selected bodies instead of all bodies, which is the normal default, and then click on the handle, which is to be cut. If we don't do that, what will happen is both the handle and the jug will be cut at the same time. Let me back up for just one moment. When the handle itself is created, make sure that merge result is left unchecked also. This way, the handle, when it's created, will be made as a completely separate body from the jug. And you should see in this folder here, it's the solid bodies 2. The one solid body, when I click on it, will be the jug main boundary. The second will be the handle. Step 4 is going to be to copy this line from the front layout, stretch it out a little bit, and then use that to cut away this excess material from the jug area. Here we see that line copied from the front layout and the resulting cut. Make sure we cut to this side, not to this side, and also down at the bottom of the property manager for the cut, make sure that selected bodies is checked instead of all bodies, and make sure that the only thing that is selected is the boundary for the jug. Otherwise, this handle will be cut at the same time. The next step now is to copy this line from the front layout and use it to trim off both this top area of the handle and this top area of the jug. Here's the copied line. It's a good idea to grab the end points of the spline and drag them out just a little bit to absolutely guarantee that they are beyond this boundary that was originally created. Do the same at this end too. Otherwise, there's a possibility that this cut might fail. Again, make sure we are cutting upward. And in this case, the feature scope down at the bottom should just be left on the default for all bodies, which means that this cut will cut both the handle and the jug. It's interesting to note that once we've made this cut, we finally can see what the shape of our jug is going to be from the top view. This shape is a combination of the shape of the original boundary with this cut passing through it. And we don't know for sure what exactly that's going to look like until we've completed this cut operation. So if we aren't too happy with the shape of this when we are all done, we might have to use a trial and error method of going back and tweaking on the profile sketches to get them to look just the way we want so that the finished result gives us the sort of a graceful shape that we desire. In a later video, we'll see a way to get a more predictable result. The next step is to build this bridge that's going to go between the handle and the jug. This is one of the more difficult operations. Rolling this forward, we see the bridge between the two. Our goal is try to blend this bridge into this body and this body seamlessly. And when I say seamlessly, I mean so that there is no pinch or peak along this joining edge, or rather edges. To do this, we're going to have to create a guide curve for the bottom edge that we're going to copy from the front layout, the guide curve along the front plane here that we will also copy from the front layout. Then we have an outer curve here which has to be made from two sketches that are projected together. And those two sketches, once they're projected together, should be blending smoothly into this upper edge here and this upper edge here. The first guide curve we create will just be a copy of this one from the front layout. Using convert entities, and that's all we have to do. The next one will be a copy of this curve from the front layout, but we need to trim it back to this point and this point. Again, in its own sketch on the front plane, copying this line. And probably the easiest thing to do is maybe copy this line and this line as well using convert entities. Simply trim these excess pieces of line away. This will leave these endpoints blue, and we can just make a coincident relation between the endpoints in this point here, in this endpoint, in this endpoint here. So now we're just using this piece of a much longer line. The next step then is to create this projected sketch that's going to go in this area. The first curve we need will be, again, a copy of this upper curve. We'll be tempted to think that we need to trim that back to these points like we did before, but we won't need to because the curve that we're going to draw out from the top view is already going to be trimmed back to those points, and the projected sketch will be limited by the shorter of the two sketches. So once again on the front plane, I'll copy this upper curve, and I will not bother even trimming it back. Now I'm going to go ahead and hide my front layout because I don't need it for now. And then on my top plane, I'm going to draw a curve that's going to bridge between this edge and that's going to be projected with the curve that I just created a moment ago. What I want to do is make this new curve a spline that's going to be equal curvature to this curve and this curve. I'm going to copy this edge using convert entities and copy this edge using convert entities. Then I'm going to draw a spline between them. Pre-select this curve and this curve, make them equal curvature. Pre-select this curve and this curve, make them equal curvature. Then I'm going to change this curve and this curve to construction lines because I don't want them included in the actual projected curve. So now I have this sketch, which will be used for the bottom. This sketch which will be used for a guide curve on the front plane. This longer sketch, which will be used as a projection with this sketch. So I'm going to say Insert, Curve, Projected. Select sketches 20 and 21 here. It doesn't matter that this sketch goes all the way to the end of the jug. Because this sketch is shorter, it's going to limit what the resulting projected sketch is, as we see here highlighted in yellow. So now I've got bottom guide, top guide on the front plane, outboard guide, which is a projected curve. Now it's just a matter of making my boundary using everything that I've got. I'm going to make a boundary that goes from this face to this face. In the past we've done some boundaries that have gone between faces that were parallel to each other, but there's no reason for the faces to have to be parallel. For direction 2, our guide curves. Then I'm going to go back up to my faces and change them to curvature to face. Now what I'm going to do is turn on the zebra stripes to analyze the blend between this bridge and the handle and the main jug. So here we see the zebra stripes do connect together. There's no shift between them. But we see that they change their direction pretty severely when they cross the join line. What this means is that these two surfaces are tangent to each other, meaning that there's no peak or valley between them at the join line, but the radius of curvature of this surface changes dramatically after it crosses this line. So we wouldn't feel a step or anything like that if we moved our finger across it, but our reflections will change very rapidly across this join. Same thing goes here, where the zebra stripes connect up with the handle, but again they change their direction very dramatically the moment they cross over the seam. So this is smoothly blended together, but the radius of curvature of this area is not the same as this area. This is in spite of the fact that we took pains to make sure that the curvature would be the same across these surfaces. Why it's not actually giving us the same curvature, I can't say exactly, but probably because this area is just very radically different from this surrounding surface and this surrounding surface, and Solidworks is just simply having too much trouble meeting all of our conditions. The steps we just completed with reference to the example file were steps 8 and 9, 6 and 7, Step 10, which was projecting 8 and 9 together, and then Step 11, which was taking all these pieces and putting them together to create this boundary. The next step is simple enough. We're just mirroring the entire body. Make sure when you mirror this that you mirror the body, not mirror the features, because there's many features in here. If you have to mirror the features, it's very time consuming. When you mirror the body, just select on the front plane, mirror, ignore the features box, go to the bodies to mirror box. Right now we have a one joined up body. Just select that body. That will get us everything at once. That was step 12. Step 13 is just to add a 0.1 millimeter radius to the base of the jug. Step 14 is to shell everything. We're going to shell at a 0.05 thickness. We're going to select all 6 of these top pieces to be excluded from the shell. We're also going to select this little bottom surface of the handle to be excluded as well. This way, and this is the way the actual jug is built, this handle is open at the bottom so no water will collect in it. The last 2 steps are just to add a .02 fillet to the upper edges so that we don't have any sharp edges on the top, and .02 fillet to the edges at the bottom of the handle. So we notice that in some cases you add fillets before making the shell and sometimes after the shell. We add fillets before the shell is completed if we want the fillet to shell inward. So here we see on the inside of the base is a smaller fillet, which was the inset shell, this outer fillet here. Whereas these fillets on the outer edges here and here are very tiny fillets and would not be able to be included in the shell because they are smaller than the shell thickness. So we actually add these after the shell is completed. So let's take a look at the jug with real view graphics activated. This is a feature of the graphics cards in some laptops or desktop computers. Most of you probably won't have this, so you won't be able to look at your models this way. This allows us to see reflections on the fly. And what we want to look at is this area here. We can see that the reflections connect up through this area, but they do make this abrupt change in direction. Same as this area here. So we see that the reflection connects together across these lines, but because they change their direction very rapidly, it means that the radius of curvature across the surface is changing very rapidly also. Also take a look at the spout area. We didn't take any special pains to make sure that when the spout was mirrored over, that this would blend back into itself properly with the mirror command. If we wanted to, we would have to slice a little section out of the middle and then build a little bridging patch to blend this together better, but that would make this particular tutorial a little bit too complicated. Finally, let's see what this looks like from the top view. Now we can see finally at the end of this process exactly what the shape of our jug with handle is going to look like when everything's been completed. Because of the method we used, we didn't know exactly what this was going to be like because we built an overbuilt boundary and then later chopped it away, which resulted in a particular shape that we could not fully predict.